Good morning. I am PRIYESHJHA and welcome to all of you from TAKSH-SHILA Model Senior Secondary School, Faridabad. Today I am going to start a new topic for class 11th of chapter Structure of Atom, and this is my 6th lecture. In the previous lecture we have discussed about Planck's quantum theory, and in this lecture we will generally discuss about photoelectric effect, photoelectric current, and application of photoelectric effect. The topic for today for class 11th is photoelectric effect and photoelectric current and photoelectric effect. So generally photoelectric effects. So what is photoelectric effect? Photoelectric effect is the process of emission of electron from a metal surface when a suitable frequency of sunlight incident on a metal plates. Okay, it is the process of emission of electrons from a metal surface when a suitable frequency of sunlight incident on a metal surface. For example, suppose this is the metal surface and this is sun. When the radiation of sun having frequency nu strike to the metals, their electrons excited. Suppose this electrons is here. When this electrons gets energy from sunlight, they become excited and come back to their surface, and after that this electrons remove outside the metal with an energy known as kinetic energy. Okay, and this process is generally known as photoelectric effect. तो फोटोइलेक्ट्रिक इफेक्ट में क्या होता है, सनलाइट की रेडिएशन क्या होता है, मेटल सरफेस पे इंसिडेंट होता है, एंड आफ्टर इंसिडेंट्स ये इलेक्ट्रॉन्स क्या करते हैं, एनर्जी गेट्स करते हैं, एक्साइट होते हैं, और एक्साइट होने के बाद क्या होते हैं, बाहर मूव करने लगते हैं विद एन एनर्जी नोन एज kinetic energy, and whole this process generally known as photoelectric effect. Suppose the sunlight having radiation frequency, then energy will be h nu according to Planck's, and this outermost electrons move in with kinetic energy, so their kinetic energy will be half mv square, and some energy is spent to excite electrons to their metal surface, generally known as work function. So work function represented like this, having chemical formula h nu naught, where nu naught is generally known as threshold frequency. So threshold frequency is the minimum frequency below which photoelectric effect cannot be observed. Okay, ये एक ऐसा फ्रीक्वेंसी होता है मिनिमम जिससे नीचे अगर सनलाइट की रेडिएशन है तो उस केस में फोटो इलेक्ट्रिक इफेक्ट नहीं होगा, मतलब इसके इलेक्ट्रॉन्स बाहर नहीं निकलेंगे, और उस एनर्जी को, उस फ्रीक्वेंसी को हम जनरली क्या बोलते हैं, थ्रेशोल्ड फ्रीक्वेंसी बोलते हैं. सपोज एनी मेटल्स हैविंग थ्रेशोल्ड फ्रीक्वेंसी वैल्यू 5 into 10 की पावर 14 hertz, and suppose the frequency of sunlight is 4 into 10 की power 14 hertz. So in this case no photoelectric will be observed because its threshold frequency is 5 into 10 14 hertz, but the radiation comes out to be having frequency only 4 into 10 की power 14. So in this case no photoelectric effect will be observed. तो इस केस में क्या होगा कि जो सनलाइट की फ्रीक्वेंसी, उसकी फ्रीक्वेंसी इससे ज्यादा होना ही चाहिए तभी फोटो इलेक्ट्रिक इफेक्ट ऑब्जर्व होगा, अदरवाइज नहीं होगा. ओके, सो दिस एनर्जी जनरली यूज्ड इन टू वेज. वन, टू एक्साइट द इलेक्ट्रॉन्स and spend some energy known as work function, and after that remaining energy required to give kinetic energy. So the energy comes out from sun in utilizing two ways. One is W naught, it is also known as W naught plus kinetic energy. The energy of sunlight generally known as written as h nu, and work function h nu naught, and kinetic energy half mv square. So this is the mathematical relation for numerical problem to find out the work function, kinetic energy or energy of sunlight. Suppose we have to calculate the kinetic energy of electrons. So in this case kinetic energy will be from this E minus W naught, and E written as h nu minus h nu naught. So we will take common h from this. So the kinetic energy will becomes nu minus nu naught. This is the formula for calculation of kinetic energy from a given data. If we have given to calculate the work function, they will find h nu naught. H is the Planck's constant having value 6.6 into 10 to the power minus 34 joule per second, and nu is the threshold frequency. It will be given. Okay, and the next one is photoelectric current. Photoelectric current. So what is photoelectric current? So photoelectric current is the current in photoelectric effect. General photoelectric effect is the process of emission of electrons from any surface, and when these electrons move with kinetic energy K, they must have a energy, and this energy converted into electrical energy known as photoelectric current. Okay, तो इसको हम क्या बोलते हैं? photoelectric current बोलते हैं. And we will use a metal surface having low value of threshold frequency, because if the radiation of sunlight is very low, then in this case electrons can also be removed from their surface because their kinetic energy is their threshold frequency is very लो. तो हम ऐसा मेटल्स यूज करेंगे जिनकी थ्रेशोल्ड फ्रीक्वेंसी की वैल्यू क्या हो? लो हो, ना कि हाई. तो सो वन क्वेश्चन कम्स आउट इन अ पेपर. वी विल यूज लिथियम मेटल और सीजियम मेटल इन फोटो इलेक्ट्रिक प्लेट. सो we will generally use cesium metal, not lithium metal, because the size of lithium metal is very low and their electrons are strongly bonded to the nucleus, but the size of cesium is very large. Their electrons are loosely bonded to the nucleus, so the minimum energy required to excite the electrons. So the excitation of electrons is easier in the case of cesium, and it is very difficult in case of lithium. So in case of lithium, much amount of energy required or much amount of radiation is required to excite the electrons, but in case of cesium, low radiation is applicable to eject the electrons. So we will generally use cesium metal in photoelectric plate, not a lithium मेटल. तो एक क्वेश्चन आता है. नेक्स्ट एक न्यूमेरिकल देखते हैं इससे रिलेटेड. कैलकुलेट काइनेटिक एनर्जी ऑफ इलेक्ट्रॉन्स when sunlight having frequency 10 की पावर 15 hertz and threshold frequency of metal is 7 into 10 to the power 14 hertz. So how we will calculate kinetic energy from the given data. We have given generally nu 1 into 10 की power 14 hertz, and this is the threshold frequency. Nu naught is equal to 7 into 10 की power 14 hertz. We have to calculate kinetic energy. So according to formula, kinetic energy is equal to h nu minus h nu naught, common comes out to be h. So this becomes h nu minus nu naught. On putting the value, h equal to 6.6 into 10 की power minus 34, nu 1 into 10 की power 15 minus 7 into 10 की power 40, 6.6 into 10 की power minus 34, 10 की power 15 can be written as 10 into 10 की power 14 minus 7 into 10 की power 14. So the common in this 2 is 10 की power 14. So this 6.6 into 10 की power minus 34 into 10 की power 14, that 10 minus 7. So this becomes, on solving, 6.6 into 10 minus 20, because minus 34 and plus 14 becomes 24, and this becomes 3. So on calculation, this will gives 19.8 into 10 power minus 20 joule, or 1.98 into 10 power minus 19 joule. So the electrons will move a kinetic energy with 1.98 into 10 power minus 19 joule. Okay, and the next one is application of photoelectric effect. Generally photoelectric effect is used for making solar cell, which is used for the use or purpose of bulb, for application in the TV, radio, and in etc. So these are the applications of generally photoelectric effect.